Hi, everyone, and welcome to the Security and Observability track. I'm your host, Patrick Akil, currently consultant at Aviad, and I also have a podcast. Check out Beyond Coding. And I'm here with Aviad Moore for his session on observability across serverless, asynchronous, and managed services. In the chat, there's a Q&A, so leave your questions there, and we'll get to them at the end. That's it. Have fun, Aviad.
Okay, thank you, Patrick. Thank you so much. So let me share my screen and we can begin. Okay, so today we're going to talk about observability, which is a very important thing, and we're going to focus on specifically on serverless and asynchronous applications, especially there because it's very interesting, and we'll talk about why it's important, how serverless changes everything when you go to observability, why it's not exactly like we did before, and we'll get to the main challenges, which is this is the interesting part. Why is it not as easy as just adding tracing to other options? But most importantly, we'll talk about solutions, right? I don't just want to say, hey, these are the issues. I also want to suggest some solutions. You can try them yourself, and I hope that you'll get a lot out of this session. So a few words about myself. I'm Aviad. I'm CTO, co-founder at Lumigo. Lumigo is an observability platform. We look at the highly distributed systems about serverless and containers. I've been in the development world for almost 2 decades, which makes me sound very old, but I don't feel old at all. I have an amazing wife, three amazing girls. We love to play Settlers of Catan. And I mainly like building things using technology and then hopefully seeing people actually using it and getting something out of it. At Lumigo, as I said, we're a serverless monitoring, serverless observability platform. What I want to say is from our day-to-day, we get to see a lot of users, how they use their cloud accounts, what are the issues that they run into, what are the challenges they have when they want to get to observability. But also, I think as important is our own backend is cloud native, a lot of serverless, a lot of containers. We use Fargate, SNS, SQS, Kinesis, a very long list that allow us to build this very scalable platform. So a lot of the challenges that we talk about are not just things that we saw in other places. These are challenges that we got ourselves that we had to overcome. And this is what I want to share with you today. So let's begin. First of all, let's talk about serverless. And when we say serverless, we first need to agree about what serverless is. And I don't want necessarily to go into the definition, which talks a lot about having somebody else do the work for you, having somebody else think about the scalability, the robustness, even the pay as you go. That's all interesting, but I want to say that serverless is much more than functions. When we were talking back in 2015, 16, maybe even 17, there was a lot of let's call it confusion between serverless and functions as a service. But it's very important to understand that serverless is so much more than just functions. It's for your database. It can be, for example, DynamoDB, API gateway, of course, Lambdas as the compute, but then for file storage and a lot of third-party SaaS. All of these together make up a serverless application in the cloud. And this is important to understand, not just because to know what serverless is, but also when we say in a serverless environment, it maybe means that you don't even have Lambdas. Maybe you have a lot of containers, but you're using Kinesis to stream the information between them, and you're using API gateway to communicate to the outer world, and you actually have serverless in your environment. So a lot of cloud native applications are actually serverless or partly serverless in their very nature. Now, this doesn't have to do with any specific cloud, Google Cloud, Azure, of course, AWS. I am going to focus a little bit more on AWS just so I don't have to keep, this whole talk at the generic level. So I want to use actual examples. Most of them will come from AWS Cloud. So let's talk a little bit about serverless impact. So when we say serverless, other than using all these cool new technologies, which are great, how does it impact my architecture when I come to plan it, when I actually run it, when I have issues in production? So there's a lot of things. I want to talk about three main changes. One, we're talking about nano services. Nano services are maybe the next step after microservices. Some will say they're a type of microservices, but the thing about why I call it nano services or microservices on steroids is because we break down everything to the atomic level. It has a lot of strength, meaning that each table in the database I can spin up whenever I want. I put the functions as a different component. They don't sit together like in a microservice, having all that this specific microservice needs. It's torn down into even smaller atomic parts. Uh, it's great, meaning you can have a lot of small changes. You don't need to necessarily all the time look at the full picture when it's not absolutely necessary. It does mean that it becomes harder and harder to understand the big picture. Once you do want to understand how the system looks like as a whole, how does one thing being down, how does it affect all the others, it becomes harder, and we'll talk about that. It also means there's a lot of async communication between the services because they're decoupled more and more, which is, again, very good practice when building a robust architecture, but it does mean that it brings new challenges into the observability. Second impact, that it's fully managed. Okay, this is one of the best parts of serverless. You let somebody else take care of all the hard parts for you. Well, not really all the hard parts, but a lot of the hard parts for you. Uh, it's amazing, allows you to focus on what makes your business the best and not having to do what a lot of other people can do for you. But it does mean that it becomes harder to pull information that it's important for you because you don't have any place, for example, to put an agent on your SNS, on your SQS, on your AppSync. You can't go into the code, you can't collect the specific traces that you need and you want, or have a deeper understanding of the type of errors you have. So as long as everything is okay, that's great. When you want to start fixing things, you can't, of course, go into the service and fix it yourself. But if you want to know how the issues are affecting your system, it becomes harder. Last thing is the cost paradigm change. Um, you have to understand how the architecture you build is going to affect your overall cost. It's much harder to predict because it's pay as you go. But if you build it correctly, the cost is going to be lower than it was before. So let's talk a little bit about serverless challenges. Okay, there's a lot of good stuff. Some of the challenges, one is the ability to identify and resolve issues. Uh, we'll see an actual example of why it becomes harder. But basically, you have a lot more moving parts. It's a much larger puzzle. So once you have an issue, the ability to get to the root cause becomes much harder. So if you have an issue, for example, an alert is on a Lambda, which is crashing, you take a look, and that's because which is the and it happened 2 minutes before it started. That's super easy, and it's really, it doesn't have to do with serverless at all. It doesn't matter if you're working on lambdas, on containers, or even if you're working on the Linux kernel in a real actual machine. You solve it the same way. But sometimes you get an alert, you look at the code and it hasn't changed in the last 90 days. So you understand there's an issue, but it's somewhere else in the system. And that's where it gets interesting and it's harder to resolve. And we'll take a look at an actual example in a second. And the second challenge is visibility. So understanding is, how is my system as a whole? Okay, I can get information about the different components in my system, but do I know how does my architecture look like? Since it's changing very rapidly, just because you can, if you have a good CI/CD in place, you can have a lot of changes even in one day. That's a great thing. I don't think it's something that needs to be stopped, but it does mean that having somebody understand how does my architecture look like right now, not how we envisioned it, not how somebody drew it on the whiteboard. And sometimes you get 5 people around the table from different teams, and they'll each tell you your architecture looks a little bit different. So that's a real challenge, and we'll take a look at how we can solve that. So before we continue, I do want to put a spotlight on asynchronous patterns. And why asynchronous? Because we see that a lot in the new cloud applications and architectures, which are cloud native, have a lot of serverless in them. And that brings a specific challenge. So again, first let's agree on what is an asynchronous pattern. So the most basic one is, for example, if you have two lambdas, is one lambda calling the other asynchronously. You have these examples, but the more common example is when you actually have something between the two computes, between the two lambdas. So I have a pattern taken from Jeremy Daly's examples. And here we have an API gateway triggering a lambda, which is DB. That DynamoDB actually triggers a stream, which is similar to Kinesis. And that in turn calls a different lambda, which continues to do other things like call RDS and SQS. Now, the thing is that these two lambdas are actually calling each other, right? Every time the first lambda runs, the second lambda will run at some point. But at no point in time, direct communication between them. They actually have two components between them, and it's completely asynchronous. So if I want to go and try to trace this call, try to understand exactly what happened, I have to go through the DynamoDB and through the DynamoDB stream in order to make the connection between the first and the second lambda. And of course, to the first and second lambda, I can make all the changes I want. I can add information to their code, so I'll understand that they're connected. But to the DynamoDB and the stream, something that I can't touch. Of course, we said it's completely managed. I don't have any ability to affect what's running there. I can make some changes in the data being passed, but that's usually not a good idea, as we'll soon see. So now that we know what an asynchronous pattern is, let's look at an example, okay? Let's look at actually troubleshooting serverless. It's 2 a.m. in the morning. Let's take even a Saturday in the night. Let's take a Saturday night. So I'm really, really asleep, and we get an alert. So when you get an alert, usually you don't have all of this nice understanding of how your system looks like. And this is a real system. This is taken from Jan Kui's example. This is actually a system that he built. over serverless technologies. Usually, what happens when you get an alert? You get an alert only in the specific component which has issues at the moment. So in this example, you can see the Lambda, which has this red triangle over it. You get an alert, let's say, to your Slack that it's crashing. Um, that's great, but you have to remember I'm very lazy, and if I don't have to wake up at 2 a.m., I really rather to as quickly as possible. So in order to go back to sleep, I need to understand the fact that this Lambda is crashing. How bad is it? Is it something terrible? Or maybe it has no effect on my production and I can go fix it Monday morning. So first thing I need to understand is how is it affecting my services to my customers, to my users? So for example, I want to understand, are there any APIs, any external APIs that I'm providing my users that are having issues right now because this Lambda is crashing? In a very simple world, each Lambda would be connected to exactly one API, but usually that's not the case. If you're building uh, your services in the right way, you're reusing your code, you're reusing your internal APIs. So one internal API, there's a good chance it's serving a few external APIs. In this example, in order to make it hard, let's say I know that this Lambda is somehow is either serving process payment or what. Process payment is very important. It's the way that my business is getting money, right? It's processing payments from my users. And Lunchbot, it's the way that my developers are ordering food. So it's important. I want them to get lunch, but maybe at 2 a.m., it's not that important, right? I can wait for Monday morning and solve any issue I have there, and it will be ready by Monday noon when they want to have their lunch. So I really want to know how this Lambda is connected to either one of them. Now, what you have to remember is here we have a very clear diagram of my system. But actually, I don't always know how the system really looks like. So first of all, if I'm very, very lucky, I have an architect in my team that always keeps this up and has a diagram which I can pull and start looking at. But in other cases, more common cases, nobody keeps this always up to date. The architect has other things to do, or maybe there were even changes that the architect wasn't aware of. So first of all, I need to get some visibility in order to understand what potentially this Lambda can affect. Now, let's say I have this visibility. The next part is to understand in this specific crash, who is being affected. Because in the best case, this Lambda is actually crashing every time that it's running, right? It's consistent, and I know it's affecting everybody, so it's a no-brainer. I need to fix it quickly. But when it crashes only some of the times, it means that the debugging is much harder. So now it doesn't only help me that I know it's connected to these two APIs. I need to know every time it crashes which API is being impacted. So I need to be able to make all the transaction from the Lambda back upwards towards the API. Once I have that, and let's say it's process payment, so I know that it's important, I still have a chance of going back to sleep if I only knew users are being impacted in this specific API. So it's not enough just to know which API, because if I could check, if I see it's a VIP trying to pay me a lot of money, okay, that's very important. I'll get all the team awake and we'll fix it as soon as possible. But maybe this is just a developer from the team running some tests on the system, trying to see if it can somehow cause issues on purpose, which is nice, but again, doesn't have to be fixed. It's not that important. So I don't just want to see what API was triggered. I also want to understand the full context of that API. I want to know which user, hopefully some more details about that API. And in a serverless environment, it's not easy because when we have a very downstream crashing, a lot of time it already lost most of the original context just because it doesn't need the original context. But if we have the correct tracing, I'm able to correlate each and every Lambda invocation, and in this case, a Lambda crash, I can correlate it back not only, which is up there in the process payment, I can also correlate it to specific context, and in this case, which user is running. So I can see now, for example, it's a user, which is very important. Doesn't matter how lazy I am. Of course, I need to wake up and fix it because it's important. Let's continue. Now let's talk about this debugging can look like. So out of the box, I have a lot. In this case, we're talking about AWS. So I have different AWS solutions when we're talking about logs and metrics and tracing. Okay, so let's say a few words about that. When we're talking about logs, metrics, and tracing, these are a lot of times called the three pillars of observability. It's important to say that just having them, metrics, logs, and tracing, doesn't equal observability, but they are the basics. So metrics are is the way to understand that there is an issue, that something changed. You can get a lot of information, aggregate it, and then see that there's a spike in the latency. There are crashes in places there weren't crashes until now. That's metrics, which is great. Then we have logs, which give us more information. Of course, the developer needs to add it to the code, but then he can add information he wants. So for a specific crash, you can now understand, hopefully as much information as you needed for that specific crash. So even I'll jump back to the example we just looked at. If I have metrics and logs for each of these components, that's amazing. I'll be able to understand exactly, for example, there was a crash and hopefully some information about that. But in order to understand how everything is connected to each other, that's where tracing comes in. That's where distributed tracing allows you to look at a distributed system and see not only how does my overall architecture looks like, but also exactly the specific calls being made, and each time to get to the root cause as quickly as possible, because I can see all the different components who took part in this specific transaction. So distributed tracing allows me to get the full picture, allows me to correlate the metrics and the logs we talked about a minute ago, because now it's not just metrics all over the place for different invocations, for different components, for the AppSync, for the S3B. If I'm able to correlate all of them together based on my distributed tracing, that actually allows me to get a picture sense out of those metrics and logs. So as I said, let's talk a little bit about how I can get that tracing and not only look at metrics and logs. There are different solutions for metrics and logs, but I don't want to get into that too much, because in asynchronous environment, in serverless environment, you can use similar tools that you used in other places. The real thing that becomes harder is tracing. So we're going to talk about three overall options. One is what here is called CloudWatch and Friends, which is basically what you have out of the box. Every cloud vendor gives you some solutions out of the box, which you can use. We'll talk about the pros and cons. In the AWS, for example, you can use X-Ray for tracing, and CloudWatch logs for logs, and CloudWatch metrics for metrics, of course. Uh, it's great. It's a very good place to start with. It's there when you start your first application. You don't have to think about it too much. It's very, very, very good. And another good thing about it is it has AWS support, or Google support, or Microsoft support, whatever you're using, which is always a great bonus. The cons is it's much more complicated, especially when you want to understand how everything is correlated, okay? Because you have traces, you have logs, you have other things, but they're not all correlated, which is very important for observability. Uh, Async support, looking at places where we saw as an example that DynamoDB, which connects to Lambdas, you have only partial support for that. So you don't get full visibility. You actually get a number of subsets of visibilities, but you don't get to see the full picture. It makes it harder to query and harder to understand the business impact. The second possible solution is the homebrewed and the open source. So you have a number of those. Uh, I want to give two main examples here. One is what you can build yourself. You can place in different places in your code. For example, every time your SNS makes a call, you can add an ID to it, and then you can write a log which outputs that ID. At, at the same time, every time a Lambda on the other side of that SNS receives a call, it can also print out that ID and print it to, gives you the ability to make the correlations between two sides of a Lambda. That's very helpful. So it's no longer just looking at logs, hoping to find some connection between them. You can actually see the correlation inside it. The issue is that you have to write all of this code. So the more specific you want, the more fine-tuned for your specific needs, you'll want to be using that. But it does mean that each and every place you're writing code, every time you're calling an SNS or an SQS or Kinesis, anything else, you need to be sure that you add it to your code, or else it's worthless. You also need to be sure that you print it out every time. So what I recommend here is to automate it as much as possible. So don't add it directly to your code. For example, you can build an SNS library which wraps the original SNS and adds this ID every time. And it goes the same to SQS, right? Don't add it really every time you see it in the code, but write your own library or use some open source, which will add this ID, and also call this library every time a Lambda is being invoked by an SQS. There are different examples that you can find out there. Power Tools is a great example for that. Remember, you have to output everything to your logs. So also, whatever system you're using, add it. It's a good place to say wherever you can use structured logs, and be sure to output that metadata every time you can. It's tailor fit. It's supported basically by any vendor because you write it, and it's not cloud specific. It is very high touch. It's very hard to do it over managed services because you can't add anything from your code to a managed services, and a lot of components are not really included. Now, here I want to point out there are which you can use, which do more of for you. Specifically, OpenTelemetry today, the main open source, it's the son or daughter of Open Tracing and Open Census. It's a clearly defined protocol of how you should send traces. It has different libraries at different maturity levels that you can check out and use according to your runtime. And then, of course, you need to be collecting all of those traces. You can use Jaeger for that. There are other open source options in order to see everything you got from that. For example, here, this is something that you can see in Jaeger. You can see all the traces in a runtime So it's not just one trace, but everything together. But again, for example, Jaeger this is mostly what you can. It's not easy to see graph view or other views that you would like. So the open source, which is, I put it under homebrewed, which is not exactly the same. There's a lot of blogs about it, and I think telemetry is going in definitely in the right direction. We're even using it in some places in Lumigo, but do check out its maturity level for your specific needs. And remember that it's not only about generating the traces, you also have to collect those traces and make sure you can see it wherever you want. The last option is our serverless monitoring platforms, third-party vendors. Lumigo is an example for that, which are dedicated for this, allowing you to see all the different important parts that you want to get in observability in one place. They're SaaS. You don't have to deploy anything on your side, any compute on your side. Another very, very important point is they're fully automated. The automating is important just because not only to make your life easier at a single point of time, but also because there's code being written in different teams in your organization. Things which are not automated are usually getting lost over time, because you need to have every developer in every team remember to trace every Lambda. When it's automated, you can be sure that at the general level, you're going to get observability. The tracing is going to happen, and you don't have to teach each and every developer to trace and how to trace and in different runtimes. This is taken care of for you. So it's a classic build versus buy, where do you need to build everything, or is it automatically going to happen for you and you don't have to spend the resources on that? So we were talking about identifying and resolving issues. You get automated alerts, understanding cost. You can get insights into that, and visibility for the big picture. You can always get an up-to-date map of how your system looks like and see a clear view. You don't have to go to the whiteboard, try to remember. You can actually see a live view of how my architecture looks like at this exact moment. And of course, the cons is it's another third party you have to get in, and it does more than just tracing. So if you're just focused on tracing, you'll get more than that. But the pros is you get a best of breed of what you're looking for, and it's, I think the main thing here, that it's very low touch. You don't have to invest the time in it. So here we can see a few examples. This is how you see a system map, and this is a very simple system map. You have, most cases you can get dozens, hundreds, even thousands of components. But even if you have only a few components in your architecture, automatically being able to understand how they're connected is not just nice to have. It also, for example, allows you to develop much quicker, because every time you make a change, you don't have to try to remember who's going to be affected. You go to the system app, and it allows you to much faster developing cycles. You can see all the different transactions in one place. So it's no longer looking at specific invocations, but you can get a very visual view of all the transactions that you have, the different issues you have there. And then you can always do a deep dive into each and every transaction. So you can see an API gateway calling a Lambda, that Lambda, so on. You get that all in one place. Automatically, you get all the different logs correlated to that specific transaction. So it's no longer looking for all the logs of one function and then trying to correlate it to logs from another function. You can see the specific logs that started with the API that is maybe causing issues, maybe has high latency, and then searching only on that subset of logs, which really reduces the time of work from hours to minutes. After that, you can check out a lot of information for each and every call that was made. So it's not about being able to see the connection between the components. It's not only that, but also a lot of metadata, which is helpful and can sometimes even replace the logs. For example, you can see the event, the trigger data that happened for each and every Lambda. You can see the output every time the Lambda or a container called either an AWS component like DynamoDB or an external one like Twilio. You can see exactly the call and you can see the result. That saves a lot of times. It's not going to see an issue and then starting to add a lot of prints to your code, hopefully reproduce it and then understand what happened. Automatically, all the information you need is collected for you without you having to decide in advance. All of that really allows you to get the debugging time and debugging energy to much lower numbers than you're used to. So main takeaways, serverless changes everything. We're looking now at nano services, which are highly distributed, a lot of asynchronous patterns, which make the tracing much, much harder. And we saw different solutions. You have out of the box solutions, you have homebrewed and open source solutions, and you have dedicated platforms which do the heavy lifting for you. So I hope all of these were helpful and allowed you to understand the different ways you can go along. And by the way, you don't have to stick to one solution all the time. You can try them out. You can even, evolve them as you go along. Maybe start with the out of the box and then choose something else. But I think the most important thing is, test it out. Usually, especially the platforms are fully automated, and also some of the open source. So you can try it out, put some of the open source in, and check it. And if you have any questions about your specific environment, I'm happy to answer anything that you have offline. Feel free to contact me, either email, Twitter, or I'm sure you'll find the way. So thank you. We have a few minutes. I want to stop here to see if there are any questions right now.
I love the talk. I actually come from an operations background, so observability is key in whatever you do, and I can very much relate to getting calls out of bed when you're on call duty
Yeah,
and checking your system. There
definitely.
were no questions yet, but I do have one for
Mm-hmm.
you.
Mm-hmm.
So I like the solutions and the options that you gave, but since a lot of stuff is managed now, serverless and managed. Um, when you do get a call, for example, when you're on duty, can you also define your metrics or your alerts so much so that you can define if it's a code issue or, for example, a managed platform issue? Because
Mm-hmm.
if it's a managed platform issue, there's not much you can do. You can check it, see, okay, it's actually that application. We have an SLA with them. They should be online in a few minutes. Um, but that alert
Right.
would still wake you up.
Right. So, Patrick, I think that's a great question because even in managed services, there are two options. So,
Mhm.
one option is exactly like you said, there's a downtime in the specific service. It happens from time to time. Um, and, if DynamoDB service is down right now, there's nothing I can do. But a lot of times the issue comes from the way you're accessing the service.
Mm.
So if you take a look at the traces, uh, for example, you can see that maybe you have a schema violation. So there's an issue that the managed service is throwing, but it's actually happened because you're calling the API in the wrong way. So you need to make the difference between the two of them. Usually from the alerts, yes, the answer is you can understand which one of those is the issue. But even in managed services, sometimes you can get up and fix the issue, not only wait for the cloud provider to fix it for you.
Yeah, yeah, that makes sense. It depends on how you use it. If you use it incorrectly, then that alert is very much valid
Exactly,
because you
exactly.
used it incorrectly, I guess.
Yeah, yeah.
Yeah, since everything is going, so I have a general feeling that everything is going more serverless, more high over,
Hmm.
and developers are not necessarily confronted with more of the under the hood stuff. But that seems like a double-edged sword as well, right? It's easy to use unless shit actually hits the fan, and then you need to be knowledgeable about what you're using. I mean, the image you showed about the landscape, right? Those hops in between, all those serverless applications in between. It's quite a lot of stuff to digest.
I agree, and I think it only really gets interesting when there's problem, right? When the
Yeah,
shit
right.
hits the fan, and that's exactly the point where you don't want to start investing time every time you have a bug to somehow get all these full transactions and the full picture. And that's why I think that because in serverless we do a lot of things automated, right? We have a lot of other people taking care of the services for us, and same goes for observability. Wherever you can, you know, let somebody else take care of it for you, so you can automatically get all the information you need and go back to fixing it and continuing whatever you're doing, either sleeping or continuing your work on developing the great next thing.
Yeah. Yeah, the only thing I think is observability is hard to do upfront. Right? What I've seen usually is that something goes wrong, and then we work on our observability so it doesn't happen again in the future. But how do you make
Right.
sure it's there upfront, or is that it's like insurance basically?
Right. So I think that the more people use it or aware of it, they see that it helps them in a lot of small cases, everyday cases, not only in the big fires when all production is down. And usually, after being used one or twice, people understand the value of it, so they get it baked in, and they won't go to production without it. And we actually see more and more people using observability tools also in the development phase, because even in the development phase you're working on a distributed environment, so it saves you so much time. The awareness is getting bigger and bigger, so it's not only after you had your first fire only then you get observability in. People just want to take advantage of it as quickly as possible.
Yeah, I think the more mature the team is, the more serious they will take kind of traceability and observability, because
Right.
they know once there is an actual issue, they'll be able to fix things in a nice and fast way. Basically, if you can't see what's going wrong, then
Hmm.
it's a big issue. Yeah,
I agree, and our own is exactly this kind of architecture, when it's very easy, if you don't have the right tool in place, to get lost. And we know from our everyday use how important it is to get observability.
yeah, yeah. I get that. I'm wondering though.
Mhm.
So there's a few more questions, but I'm gonna keep this one short. I'm assuming that everyone in the team should know their way around any observability tool that you're using, right? Even if it's just okay, we need to zoom in, see where it actually goes wrong from an error to the actual point that it triggered. Is that
Mhm.
doable within a whole dev team, you think?
I think it is. It's very important. It
Yeah.
empowers everybody on the team, allowing them not only to take care of issues, but even to develop quicker because they're able to understand the system. And that's usually where very easy and understandable UI and UX comes in. That's exactly where it is. Although developers always like to work with a console, but because it's a tool that they won't necessarily be using every day, every time, every person on the team, it's very important that once they just open it, they immediately understand what they're looking at. It's not easy to get, but I think to get there to a place where it's so easy to consume all that information, that I think that's one of the key points at a good observability tool.
Yeah. Yeah, I completely agree with that. It really helps with regards to shared understanding of the system also.
Hmm.
I love the talk. I love our little chat at the end as well. Aviad, let me check. I forgot your last name. My bad. Aviat More, everyone.
Hmm.
Check out his socials. They're in the speaker's kind of info view. Don't know where that is. You'll probably be able to find it. And we'll be back in 15 minutes with another session. So thanks, everyone. See you in a bit.
Thank you, Patrick. Thank you, everyone.